a more detailed video on this. I'm not sure if it's working, so here's the short version. In a liquid, you don't know molar mass for it because it's mixed up with water in this case, or some solvent. For us, it's usually water. This is a SAD graduated cylinder. So we have some Ki in here, and we could look up its molar mass. The problem is that we also have a bunch of water. It's mostly water. We don't know how much without being told. So they do tell you in 1 liter of this solution, if we had an entire liter, that there would be 1 mole of it. Now, where do they tell you that? They tell you on the label. It says 1 m, and you probably haven't done that in lecture, and you may not have to do that in lecture. But now you know m equals 1 mole, or however many moles are in there, in a liter. In fact, I should get rid of that. So moles per 1 liter. It's always how much is in 1 liter. And then they tell you what is called the molarity. How many moles are in 1 liter? That's what that m is. If it's 1 m, that means there's 1 mole in 1 liter. It doesn't have to be 1 m. We could have 0.2 molar, which would mean there was 0.2 of a mole in there, or 3 molar, where there are 3 moles in there. Ours is 1. We have 1 mole in 1 liter. Now, do we have 1 mole in this graduated cylinder? We do not, but they do give you how many liters you have. So we don't have a whole mole because we don't have a whole liter, but we know how many milliliters we have. Can we turn that to liters? Sure can, because we did that with all our conversions. And milliliters, well, how many milliliters are in a liter? In 1 liter, we have 1,000 milliliters. Now, this number comes from your measurement. I don't know exactly what it's going to be. Okay. So you measure it. It might be a little different from person to person. It's going to be different from trial to trial. But you'll get a measurement for volume. You can convert that to liters. Now we know how many liters we have, and we know how many liters are in, how many moles are in a liter. So we can cancel those out. Molarity is a conversion factor we can use. So we know in 1 liter, I know I need that on bottom to cancel. Remember, this isn't always a 1-to-1 ratio, so it's important to put everything in the right spot. And then whatever your measurement is here, you would plug that in, and that would tell you how many moles of Ki you have. Notice that I never use grams. I don't use how many grams are in my sample because it's sitting on a balance and I can see how many grams there are. But I never use that. I never use the molar mass. And the reason for that, again, is because that is mixed up with water. And we don't really know what the density of that solution is or anything to use that. So this is how you would do this with a liquid. And it, again, totally different from how you deal with the potassium, from the lead nitrate. Because that's a solid, so we can just do it the way you're used to handling it. So when you get your answer, you're going to compare this to the one you got for lead nitrate, the old way, and you're going to see which one of these is your limiting reagent. So it may be, for some of you it will be potassium iodide, and for some of you it will be lead nitrate.